Now that all the parts are made, we need to work on the assembly. I'm not going to start with the main assembly. We're going to start with some sub-assembly. And here's where your headspace needs to be as it relates to assembly. You always want to start with sub-assembly. Nobody at Boeing draws the entire plane. They start with sub-assemblies. This project is not the scale of a Boeing 747 or 777. It could be. I just don't want you to have to work that hard to do it. So we're doing something that's manageable, that has some obvious sub-assemblies that I think helps you. And that's why this project exists. So we're going to look at sub-assembly. Because we're online, this is the best I can do. I can do a picture. Keep in mind that a student broke this piston just prior to this picture being taken. It's now missing. I don't know where it went. It fell off. But this piston is normally coincident with these other two along this rod. Now, just looking at this picture, let me get a little bit smaller so you can see more of it. Looking at this picture, I see some things that exist more than once. The cylinder and the piston, we've already drawn those parts, and they say 3 required, so I know that they're the same. This cylinder is the same as this cylinder, is the same as this cylinder. This piston is the same as this one, And then we have some springs that I can see there, and some screws. That looks like a really good starting place. So we are going to create a sub-assembly. Let's open up SolidWorks. I'm going to say File, New, and an assembly this time. And click OK. I have to come at this with the assumption that you have created an assembly or sub-assembly before. I'm going to move rather fast. Your book has entire chapters dedicated to assemblies and sub-assemblies. But to start off with, we're just going to, right in here, in Begin Assembly, we're going to browse for some part. And this is where I have all my required folders. Okay. Let's look at these parts. I want the cylinder. I'm going to put the cylinder in here. So I'm just going to double click the cylinder. And right now it's attached to my mouse, and I'm just going to go over and I'm going to click OK. Now, that does a couple things. The first thing it does is it selects that part. The second thing it does is that it locks it in 3D space, and it is not movable. Just keep that in mind. There's also something to note that there is a port on one side of this that needs to be coincident to the cylinder standard. So how you orient this is important. The next part I'm going to bring in is a piston. In my assembly, I'm going to insert component. I'll browse piston. Double click that. There's a piston. Let's bring in one more. I'm going to insert components. I'm going to browse. This is a piece of hardware, provided hardware. This is the spring. So you'll find the spring in here, and there's the spring. We need one more part. And you don't necessarily have to bring in every part and then start assembling them. It's just the way I want to do it. I know that the cylinder is a 1/2 inch thick, the spring is a 1/2 inch thick, and the cylinder standard where they mount is a 1/2 inch thick. So I need a number 10 32 screw and 1.5 inches long. Where am I going to get that? Well, I'm going to get that at McMaster Car. You do not want to use Toolbox for this. And there is a lot of stuff in McMaster Car, and fortunately the very first thing listed is screws and bolts, and that's what we want. And now there's a lot of choices here. We want like a pan or a rounded head screw. Here's a rounded head screw right here. So let's click on that. And these are my choices. Let's do Phillips. And now I'm going to stop selecting this, and we're going to come over here, and we are looking for a 1032, so I'll select that. The length I said we want is 1.5 inches, and that's from the end of the screw to the bottom of the head, because it's not a flathead. And let's make it out of brass. All of these features here means that they only have one. So how do I get this CAD file? Well, right here where it says product detail, there's a little CAD icon, and if I click on that and I scroll all the way to the bottom, you can download this file. And you can download this file for all sorts of things, but 3D SolidWorks is what we want, and that's the default. And we're going to click Save. And I'm going to select Open. And that's going to open the part in SolidWorks. You can't modify any of this stuff, nor would you want to. But that's the screw. It's an 1.5" pan head. And we are going to say File, Save As. And we're going to save that as hardware in the hardware folder, not the provided hardware folder, because I didn't provide this to you. You went and got that. Now you have to, this part number right here, you're going to have to remember. This part was saved in an older version of SolidWorks, so that's just alerting me, but that's the screw. What's nice is when I have a part open, when I go in my assembly to insert it, it will show up. It exists because it's open, which is kind of nice. I can just double click that, place it right there. Those are the 4 parts that we need. So to start, let's put the piston inside of it. So we're going to go up to the paperclip here. We're going to go to Mate. And we're just going to use relationships to mate these 2 things together. And right now, SolidWorks is, the blue box says Mate Selections. What do you want? Well, I want this cylindrical surface to be coincident and concentric to this cylindrical surface. And by default, SolidWorks chooses concentric. If you can see, it's grayed out there. SolidWorks doesn't always choose the correct choice. It chooses what it thinks you want based on an algorithm. Okay, but that is what I want, and I'm going to select OK. The cylinder doesn't move, but the piston will move up and down, and it'll go all the way through, but that's okay. We're going to constrain that with another mate. So the final 2 things we have is the spring and the screw for this subassembly. We need to make this spring to the face of the cylinder on the outside. So if you'll look here, we'll zoom in. This face doesn't have the port on it. The port is coincident to the cylinder standard, so that as it oscillates, it moves between the through hole and the partially through hole, and it oscillates between intake and exhaust as the flywheel rotates. Let's get that spring mated. What's nice about these springs is there's a flat spot on the face, so that's a plus. So we can select this face here and this face here. And by default, SolidWorks says, well, obviously you want those coincident, and I do. That is correct. So I'll click OK. Okay, that was the easy one. The difficult one is locating this spring on this face and holding it there. Because by nature, the spring concentric doesn't work like it did with the piston, because there is no real cylindrical surface on the inside of the spring. It's a helix. So concentric mate doesn't work. I'm going to show you how to use the construction geometry of this spring to do the mate, because sometimes that's what you have to do. Actually, frequently that's what you have to do. We need this spring to be concentric with this hole. Let's open up our design tree and let's look at the spring. Where is it? There it is, spring. And I'm going to expand the spring, and let's just hover over some planes. Ooh, an origin. Where is that origin? It's right in the center. How handy is that? Let's have that origin of the spring be our first selection. And then our next selection be the cylindrical inside surface of the hole. Now, SolidWorks chooses something that I don't want, but mathematically it makes sense. If I choose a cylinder and a point, coincident is sort of an obvious choice. Well, let's see if it'll let me do concentric. Well, it does, but I have to select that. SolidWorks doesn't choose it automatically. Remember, you're in charge. Click OK. The spring is now coincident to the face of the cylinder, and it's centered on the hole, which is what I want. Now the next thing we need to do is we need to mate this screw with the head coincident to the spring. So let's select this face of the spring, and that flat surface of the screw. Let's see what it looks like. Well, it did it, but it did it the wrong way. If you look right here, there's a flip mate alignment button. If I click that, it'll flip it around. Love it. It's exactly what I'm looking for. But now I need the screw to be concentric in the hole, and this can prove to be problematic. There should be a round surface that I can select on the end of that screw. Let's just see. I bet that circle will work. And this cylinder here, and look at that. So now we have a subassembly. We have a spring, a screw, a cylinder, and a piston. And those things together can get saved as a subassembly and then inserted into our main assembly 3 times rather than doing all of that 3 times. It's the power of subassembly. Let's save this. So I'm going to go File, Save As. This is going to go in my Assemblies folder. So this is a subassembly. I'm going to call this subassembly 1. The naming conventions on subassemblies get a little bit weird. To fully define this, it would be what? Piston, cylinder, spring, screw? That would be a pretty long name. Subassembly 1 works in this case. Something else you can do, the hardware will always come in with sketch entities viewed, so you can see the center lines, you can see the helixes, you can see all the things. If you go into, if you click the down arrow in this little eyeball icon, I can turn View Sketches off, which just cleans it up. Save that, and we will import this into our main assembly later.